On this Ram 1500 with the 5.7 gas engine, P0353 points us toward the ignition coil 3 primary, or control, circuit. In plain terms, the PCM may not be seeing the expected current on the coil 3 signal side. The truck may turn the MIL on, and depending on how the fault shows up, it can run rough, misfire, or have an intermittent ignition problem. The broad fault areas can include the fused relay output feed, the coil 3 control circuit, the coil itself, related connections, or the PCM. Before getting into circuit testing, start with the basic system checks and follow a structured diagnostic approach. This monitor runs continuously with the ignition on. The code sets when the PCM detects ignition coil 3 signal circuit current less than or equal to 0 amps for at least 2 seconds. The default action is that the MIL will illuminate. Start by reading codes in all modules and record the codes and the environmental data. Save the scan report and the related recorded data so you can duplicate the conditions as closely as possible. Then erase all codes. Turn the ignition off for a minimum of 0 seconds, turn it back on, and operate the vehicle under the conditions that set P0353. Read the codes again. If P0353 does not return, treat it as an intermittent condition. If it does return, continue with the diagnostic path. Next, look at the recorded codes. If any ASD-related codes are present, handle those first. If there are no ASD codes, move on to the coil feed circuit test. Now check the relay output feed for high resistance by load testing the 12-volt supply circuit. Disconnect the component harness connector so the 12-volt supply circuit is isolated. Connect the positive lead of the load test tool to that supply circuit at the component connector, and connect the negative lead to battery ground or a good chassis ground. Make sure the circuit is actually powered during the test. If it is a relay output, make sure the relay is energized and on. A good feed should light the load test bulb bright, and that brightness should compare closely to a direct battery connection. The load matters here. A 3156 bulb has approximately 6.0 ohms of resistance and draws approximately 2.0 amps of current. A high impedance test light that draws less than 0.1 amps is not a dependable load test. The tool should draw more than approximately 0.75 amps. The point of loading the circuit is to expose voltage drop. The example is 2.0 ohms of resistance in the circuit being tested, creating total circuit resistance of 8.0 ohms. If the bulb is bright, go on to the coil control circuit operation check. If it is not bright, repair the 12-volt circuit for an open or high resistance. If the fuse is open, check the circuit for a short to ground. Then verify the repair and confirm the code stays gone. Next, check the coil 3 control circuit operation. Use a 12-volt test light connected to a 12-volt source and probe the coil 3K18 control circuit at the ignition coil harness connector. Crank the engine for 0 seconds while watching the test light. Stay clear of the fan, pulleys, belts, and any moving parts while cranking or running the engine, and do not wear loose clothing. If the light blinks brightly while cranking, the control circuit is operating and the path moves to spark plug inspection. If the light stays on constantly, that points the path toward a control circuit short to ground check. If the light stays off constantly, that points the path toward an open or high resistance check in the control circuit. When the control circuit is blinking brightly, turn the ignition off and remove the spark plug or plugs for that cylinder using the proper removal process. Inspect for cracks, carbon tracking, foreign material, gap size out of specification, and a loose or broken electrode. If any of those conditions are present, replace the spark plug. If carbon tracking is found on the plug, inspect the ignition coil boot for damage and replace the boot or coil as needed by the condition found. Then verify the repair and confirm the code stays gone. If none of those spark plug conditions are present, replace the ignition coil and spark plug, then verify the repair and confirm the code stays gone. If the test light stayed on constantly, Isolate and check the coil 3K18 control circuit for a short to ground. The ignition must be off when checking a circuit for continuity to ground. Isolate the circuit by disconnecting the ECU and every component connector that contains the circuit being tested. Use the circuit path to separate sections where possible. Connect the negative DVOM lead to a known good ground. Then use the positive lead to probe the circuit at the component harness connector. There should be no continuity between ground and the circuit being tested. Do not probe the PCM harness connectors directly. Probing them can damage the terminals and create a poor terminal-to-pin connection. Use the GPEC Diagnostic 10436 adapter when access at the PCM side is needed. Also remember the GPEC Diagnostic adapter can add up to 1.5 ohms of resistance to the circuit. If continuity to ground is present, repair the circuit for a short to ground, then verify the repair and confirm the code stays gone. If there is no continuity to ground, continue to the coil and PCM driver check. If the test light stayed off constantly, isolate and check the coil 3K18 control circuit for an open or high resistance. The ignition must be off when checking circuit continuity. Disconnect the ECU and the component connector that contains the circuit being tested. Before measuring the circuit, measure the resistance between the two DVOM leads so you know what the meter and leads are adding. Then connect one DVOM lead to the circuit at the component harness connector and the other lead to the same circuit at the GPEC adapter. If access at a PCM harness connector is needed, use the GPEC Diagnostic 10436 adapter instead of probing the PCM connector directly. The adapter can add up to 1.5 ohms of resistance. The decision point here is whether the measured resistance is below 3.0 ohms. If it is below 3.0 ohms, continue to the coil and PCM driver check. If it is not below 3.0 ohms, repair the circuit for an open or high resistance, then verify the repair and confirm the code stays gone. Before condemning the PCM, determine whether the ignition coil caused the coil driver failure. An internally shorted or damaged secondary coil circuit may be the reason the driver failed, so do not replace the PCM until this check is done. Remove the ignition coil controlled by the driver that's set P0353 and install that coil onto another coil location that did not have a code set against it. Turn the ignition on, erase the codes, then start and run the engine for up to 1 minute. If the engine will not start, crank the engine 3 times for 10 seconds. Read the codes again. If a correlating fault sets for the new coil location, replace the ignition coil and replace and program the PCM, then verify the repair and confirm the code stays gone. If a correlating fault does not set at the new coil location, continue with the related connection checks. At this point, apply any relevant bulletins, then inspect the related connections carefully. Disconnect the PCM harness connectors, any related inline harness connectors if equipped, and the related component connectors. Look for connector installation problems, damaged locks, corrosion, water intrusion, damaged weather seals, bent terminals, overheating from a poor connection, terminals pushed back in the connector, spread terminals, and poor terminal tension. Repair any conditions found. Then reconnect the PCM connectors, inline connectors, and component connectors, making sure everything is fully seated and the locks are fully engaged. Erase the codes, then test drive or operate the vehicle under the conditions that run this monitor, and read the codes again. If P0353 returns, replace and program the PCM, then verify the repair and confirm the code stays gone. If P0353 does not return, the wiring or poor connection problem has been repaired. Keep the verification separate from the circuit testing. Anytime the path ends in a wiring repair, coil or spark plug replacement, boot replacement when needed, or PCM replacement and programming, clear the codes, operate the vehicle under the same conditions, and confirm P0353 stays gone. The key on this one is to prove the feed, prove the control circuit behavior, inspect the secondary side when the driver command looks good, and protect the PCM decision by checking whether the coil contributed to the driver failure. For more diagnostic training, visit stepdiagnostics.com.